We're back. We are back with Anatomy and Physiology 1.3, Chapter 1.3, Functions of Human Life. Learning Objectives. By the end of the section, you will be able to explain the importance of organization to the function of the human organism, distinguish between metabolism, anabolism, and catabolism. I don't know if I'm saying those exactly right. I feel like they might be words that are pronounced in multiple correct ways or accepted ways. I know metabolism, and I know what anabolic is, but anabolism, I don't think it's rhymes with cannibalism. Anabolism and catabolism, I'm gonna go with that. Provide at least two examples of human responsiveness and human movement. Compare and contrast growth, differentiation, and reproduction. Okay. The different organ systems each have different functions and therefore unique roles to perform in physiology. These many functions can be summarized in terms of a few that we might consider definitive of human life: organization, metabolism, responsiveness, movement, development, and reproduction. Organization. A human body consists of trillions of cells organized in a way that maintains distinct internal compartments. These compartments keep body cells separated from environmental threats, and keep the cells moist and nourished. Lovely. They also separate internal body fluids from the countless microorganisms that grow on body surfaces, including the lining of certain passageways that connect to the outer surface of the body. The intestinal tract, for example, is home to more bacterial cells than the total of all human cells in the body. That's crazy. Yet these bacteria are outside the body and cannot be allowed to circulate freely inside the body. So that's interesting. Just because it's in your intestinal tract doesn't mean it's in your body. It seems like that's what this is saying. Okay, we'll go with that. Crazy. Cells, for example, have a cell membrane, also referred to as the plasma membrane, that keeps the intracellular environment, the fluids and organelles, separate from the extracellular environment. Blood vessels keep blood inside a closed circulatory system, and nerves and muscles are wrapped in connective tissues connective tissue sheaths that separate them from surrounding structures. In the chest and abdomen, a variety of internal membranes keep major organs such as the lungs, heart, and kidneys separate from others. Okay. The body's largest organ system is the integumentary system, which includes skin and its associated structures such as hair and nails. The surface tissue of skin is a barrier that protects internal structures and fluids from potentially harmful microorganisms and other toxins. Great. Okay, here we go. Metabolism. Let's learn about why I have so much trouble losing weight and keeping it off. Metabolism. The first law of thermodynamics holds that energy can neither be created nor destroyed. And welcome to the viewer. You're helping me study and learn anatomy and physiology. I hope you get something from it too. And goodbye. The first law of thermodynamics holds that energy can neither be created nor destroyed. It can only change form. Your basic function as an organism is to consume, ingest energy and molecules in the food you eat, convert some of it into fuel for movement, sustain your body functions, and build and maintain your body structures. What could be so hard about that? There are two types of reactions that accomplish this: anabolism and catabolism. Anabolism, that kind of sounds better. Anabolism is the process whereby smaller, simpler molecules are combined into larger, more complex substances. Your body can assemble by utilizing energy, the complex chemicals it needs by combining small molecules derived from the foods you eat. So it's basically saying, break down what you eat and making bigger fuels that sustain the body. Okay, complex chemicals. Smaller to more complex. Simpler to complex. Catabolism is the process by which larger, more complex substances are broken down into smaller, simpler molecules. Catabolism releases energy. The complex molecules found in foods are broken down so the body can use their parts to assemble the structures and substances needed for life. So, anabolism, building up, catabolism, breaking down. Cats break things, Anna builds things. Thanks, Anna. Okay, taken together, these two processes are called metabolism. Metabolism is the sum of all the anabolic and catabolic reactions that take place in the body. Both anabolism and catabolism occur simultaneously and continuously to keep you alive. Fantastic, thank you. Every cell in your body makes the use of a chemical compound, adenosine triphosphate. Good job with pronunciations. I'm just going to pat myself on the back for these. ATP. Oh my God, I remember ATP from bio. Oh my God, I'm having fucking flashbacks. Sorry for the language. Oh my God. To store and release energy. The cell stores energy in the synthesis, anabolism, right? Anabuilds of ATP, then moves the ATP molecules to the location where energy is needed to fuel cellular activities. It's like getting the gas, the natural gas out of the ground, and then moving it to gas stations, or rather to your car. I guess the process of getting it to your car where you'll use it. Then the ATP is broken down, catabolism, and a controlled amount of energy is released, which is used by the cell to perform a particular job. Maybe I do these on their own dedicated channel instead of on this channel. Holy moly. Bah. That sounds like a lot of work. Okay. Responsiveness is the ability of an organism to adjust to changes in its internal and external environments. An example of responsiveness to external stimuli could include moving towards sources of food and water and away from perceived dangers. Cool. Changes in an organism's internal environment, such as increased body temperature, can cause the responses of sweating and dilation of blood vessels in the skin in order to decrease body temperature, as shown by the runners in figure 1.7. You can't see that. Hooray. Movement. Okay, so interesting. That's its own thing. Organization, metabolism, responsiveness, movement. Welcome to Anatomy and Physiology. Movement is the next section. Human movement includes not only the actions at the joints of the body, but also the motion of individual organs and even individual cells. That's crazy. As you read these words, red and white blood cells are moving throughout your body. Get them out. Muscle cells are contracting and relaxing to maintain your posture, which is not being maintained. I don't like sitting. I hate sitting. This is my nightmare. Maintain your posture and focus your vision. And glands are secreting chemicals to regulate body functions. Hooray. Your body is coordinating the action of entire muscle groups to enable you to move air in and out of your lungs, to push blood throughout your body, to propel the food you have eaten through your digestive tract. I had some pizza tonight. Yeah. Consciously, of course, you contract your skeletal muscles to move the bones of your skeleton to get from one place to another, and to carry out all the activities of your daily life. Oh, there they are, marathon runners. I'm looking at the picture now. Very exciting. They're sweating. I wonder what system that is. I'm not even going to try to guess right now. Then there's development, growth, and reproduction. Cool. You've got development all the changes the body goes through in life, development includes the process of differentiation, in which unspecialized cells become specialized in structure and function to perform certain tasks in the body. Development also it includes the processes of growth and repair, both of which involve cell division. So, we have neurons, which are, nerve cells. But then we have skin cells, we have cells that make up your heart. All these different cells, they specialize. So, yeah. What are those cells, like the baby cells, embryonic, stem cells? Maybe I'll learn about those someday. Growth is the increase in body size. I do that all the time. I eat too much, so I grow. That's what I meant. I'm sorry. Humans, like all multicellular organisms, grow by increasing the number of existing cells, increasing the amount of non-cellular material around cells, such as mineral deposits in bone, and within very narrow limits, increasing the size of existing cells. That sounds scary. And then lastly, reproduction, the formation of new organism for parent organisms. In humans, reproduction is carried out by the male and female reproductive systems. Because death will come to all complex organisms, without reproduction, the line of organisms would end. 1.4, we're moving on. Wait, let me just review these real quick for me. Oh gosh. Organization, metabolism, responsiveness, movement, development, growth, and reproduction. Fantastic. Do I feel good about this? I feel good about this. Okay. Welcome. 1.4, requirements for human life. I'm glad I need to figure out what exactly it takes for me to be alive right now, because I just don't know. So, by the end of this section, you will be able to discuss the role of oxygen and nutrients in maintaining human survival. Okay. I feel like I understand a little bit of that already. Explain why extreme heat and extreme cold threaten human survival. And by extreme heat and extreme cold, I mean it being 75 degrees or 65 degrees. Too hot, too cold. Gotta have it just right there. Stole that. That's a Louis C.K. joke, so I stole it. No. I'm not an original. I'm reading a book here on YouTube. Explain how the pressure exerted by gases and fluids influences human survival. Okay. Well, humans have been acclimating to life on Earth for at least the past 200,000 years. Take that, Christians. People believe the Earth is 6,000 years old, or I don't know. Okay. Earth and its atmosphere have provided us with air to breathe, water to drink, and food to eat, but these are not the only requirements for survival. Although you may rarely think about it, you also cannot live outside a certain range of temperature and pressure that the surface of our planet and its atmosphere provides. The next sections explore these 4 requirements of life. Oxygen. Atmospheric air is only about 20% oxygen, but that oxygen is a key component of the chemical reactions that keep the body alive, including the reactions that produce ATP, which we learn about in anabolism and catabolism, right? Anabolism making process that could make something like ATP, and catabolism is the process of expending that energy. Okay, great. Brain cells are especially sensitive to lack of oxygen because their requirement for a high and steady production of ATP. Interesting. Brain damage is likely within 5 minutes without oxygen. My God. And death is likely within 10. Oh no. Glad I can breathe right now. Nutrients. Great. A nutrient is a substance in foods and beverages that is essential to human survival. The three basic classes of nutrients are water, the high energy yielding and bodybuilding nutrients, and the micronutrients, vitamins and minerals. Okay. The most critical nutrient is water. Depending on the environmental temperature and our state of health, we may be able to survive only for a few days without it. The body's functional chemicals are dissolved and transported in water, and the chemical reactions of life take place in water. Moreover, water is the largest component of cells, blood, and the fluid between cells. Viscera? And water makes up about 70% of an adult body mass. Water also helps regulate our internal temperature and cushions, protects and lubricates joints, and many other body structures. Very cool. The energy-yielding nutrients are primarily carbohydrates and lipids, carbs and fats, while proteins mainly support the amino acids that are the building blocks of the body itself. Okay, interesting. You ingest these in plant and animal foods and beverages, and the digestive system breaks them down into molecules small enough to be absorbed. The breakdown products of carbohydrates and lipids can then be used in the metabolic processes that convert them to ATP. Although you might feel as if you are starving after missing a single meal, you can survive without consuming the energy-yielding nutrients for at least several weeks. That's crazy. Okay. Water and energy-yielding nutrients are also referred to as macro because the body needs them in large amounts. In contrast, micronutrients are vitamins and minerals. These elements and compounds participate in many essential chemical reactions and processes, such as nerve impulses, and some, such as calcium, also contribute to the body's structure. Cool. Gotta get your calcium. Your body can store some of the micronutrients in its tissues and draw on those reserves if you fail to consume them in your diet for a few days or weeks. Some others micronutrients. I'm finding typos in this. Okay, it's just little omitted letters here and there, missing S, added S. Some other micronutrients, such as vitamin C and most of the B vitamins, are water soluble and cannot be stored, so you need to consume them every day or two. Good to know. Narrow range of temperature. Okay, you've probably seen news stories about athletes who have died of heat stroke or hikers who died of exposure to the cold. Such death occurs because the chemical reactions upon which the body depends can only take place within a narrow range of temperatures. Yeah, that makes sense. Hey, welcome. We're talking about temperatures and how humans can only survive in a narrow range of temperatures. And goodbye. Lost my place. Just below to just above 37 degrees Celsius, 98.6 degrees Fahrenheit. Okay. When body temperature rises well above or drops well below normal, certain proteins, enzymes, that facilitate... I'm tired, y'all. I'm tired. This is the last one for the night. 100%. It's almost 20 minutes. Oh my God, bro. I'm just reading. This book is going to take forever. Facilitate chemical reactions, lose their normal structure and their ability to function. Too much heat, enzymes break down, bad, can't function. That said, the body can respond effectively to short-term exposure to heat or cold. Nice. One of the body's responses to heat is, of course, sweating. As sweat evaporates from the skin, it removes some thermal energy from the body, cooling it. Adequate water from the extracellular fluid in the body, not in the cell, is necessary to produce sweat, so adequate fluid intake is essential to balance that loss during the sweat response. Not surprisingly, the sweat response is much less effective in a humid environment because the air is already saturated with water, so it can't evaporate. Thus, the sweat on the skin's surface is not able to evaporate, and the internal body temperature can get dangerously high. And moving on, the body can also respond effectively to short-term exposure to cold. One response to cold is shivering, which is random muscle movement that generates heat. Good to know. Another response is increased breakdown of stored energy to generate heat. When the energy reserve is depleted, however, and the core temperature begins to drop significantly, red blood cells will lose their ability to give up oxygen, denying the brain of this critical component of ATP production. Okay, so that's crazy. Lack of oxygen can cause confusion, lethargy, and eventually loss of consciousness and death. The body responds to cold by reducing blood circulation to the extremities, the hands and feet, in order to prevent blood from cooling there so that the body's core can stay warm. It's like the core needs this more right now, so we're going to go and take your fingers off and your nose and your ears. Even when the core body temperature remains stable, however, tissues exposed to severe cold, especially fingers and toes, can develop frostbite when blood flow to the extremities has been much reduced. This can lead to permanent damage, tissue damage, gangrene, requiring amputation of the affected region. Not fun. Everyday connection, controlled hypothermia. I'm skipping that right now. Skipping it. Pressure, narrow range that we can survive in. Pressure is a force exerted by a substance that is in contact with another substance. Atmospheric pressure is pressure exerted by the mixture of gases, primarily nitrogen and oxygen, in the Earth's atmosphere. Although you may not perceive it, atmospheric pressure is constantly pressing down on your body. This pressure keeps gases within your body, such as gaseous nitrogen in body fluids, dissolved. Interesting. Okay. If you were suddenly ejected from a spaceship above Earth's atmosphere, you would go from a situation of normal pressure to a situation of very low pressure. The pressure of the nitrogen gas in your blood would be much higher. This is scary. It would be higher than the pressure of nitrogen in space. As a result, the nitrogen gas in your blood would expand, forming bubbles that could block blood vessels and even cause cells to break apart. I think it's basically like your blood boils in your body. Yeah, I'm good. I'm staying on Earth. Like, I'm chilling. We're good. I'm staying here. Atmospheric pressure does more than just keep blood gases dissolved. Your ability to breathe, that is, to take in oxygen and release carbon dioxide, also depends upon a precise atmospheric pressure. Altitude sickness occurs in part because the atmosphere in high altitudes exerts less pressure, reducing the exchange of these gases, causing shortness of breath, confusion, headache, lethargy, and nausea. Mountain climbers carry oxygen to reduce the effects of both low oxygen levels and low barometric pressure at high altitudes. That's why everyone in Denver is confused all the time. Okay. Homeostatic imbalances. Okay. Decompression sickness. This is interesting. It's called DCS for short. This is a condition in which gases dissolved in the blood or in other body tissues are no longer dissolved following a reduction in pressure on the body. This condition affects underwater divers who surface from a deep dive too quickly. And it can affect pilots at high altitudes in planes with unpressurized cabins. Divers often call this condition the bends, BENDS, a reference to joint pain that is a symptom of DCS. In all cases, DCS is brought about by a reduction in barometric pressure. At high altitude, barometric pressure is much less than on Earth's surface because the pressure is produced by the weight of a column of air above the body. So when you're higher up, there's less of it. Okay. Pressing down on you. The very great pressure on divers in deep water are likewise from the weight of a column of water pressing down on the body. More pressure. For divers, DCS occurs at normal barometric pressure at sea level, but it is brought on by the relatively rapid decrease of pressure as divers rise from the high pressure conditions. Higher you go in the water, the less the pressure is on your body, there's less water above you. So it's low sea level is low by comparison. Surprisingly, diving in deep mountain lakes where barometric pressure at the surface of the lake is less than at the sea level, more likely to result in DCS than diving in water at sea level, of course. Yeah, because you're already high up, pressure's already lower, so the difference between the pressure underwater and surface is greater than if you're just at sea level. Okay, good to know. In DCS, gases dissolved in the blood, primarily nitrogen, come rapidly out of solution, forming bubbles in the blood and in other bodily tissues. This occurs because when pressure of a gas over a liquid is decreased, the amount of gas that can remain dissolved in the liquid is also decreased. Hold on. When pressure of a gas over a liquid is decreased, the amount of gas that can remain dissolved in the liquid is also decreased. Okay. It is air pressure that keeps your normal blood gases. Come on, we're trying to move to the next page. Dissolved in the blood. When pressure dissolved in the blood, when pressure is reduced, less gas remains dissolved. You've seen this in effect when you open a carbonated drink. Removing the seal reduces the pressure of the gas over liquid. This in turn causes bubbles as dissolved gases come out of the solution of liquid. Great. So we're like cans of soda. Think about it. The most common symptoms of DCS, aka the BAMs, are pain in the joints, with headache and disturbances of vision occurring in 10% to 15% of cases. Left untreated, very severe DCS can result in death. Immediate treatment is with pure oxygen. The affected person is then moved to a hyperbaric chamber. Hyperbaric chamber is reinforced, closed chamber that is pressurized to greater than the atmospheric pressure. It treats DCS by repressurizing the body so that the pressure can be removed gradually. It's like, take it easy, big boy. You need more time to achieve homeostasis. That's the next chapter. I'm not going to do that part, though, because I need to go to bed. Because hyperbaric chamber introduces oxygen to the body at high pressure, it increases the concentration of oxygen in the blood. This has the effect of replacing some of the nitrogen in the blood with oxygen, which is easier to tolerate out of solution. Okay, last bit. The dynamic pressure of body fluids is also important to human survival. For example, blood pressure, which is the pressure exerted by blood as it flows within blood vessels, must be great enough to enable blood to reach all body tissues, right? You have to have high enough blood pressure to reach tissues, and yet low enough to ensure that delicate blood vessels can withstand the friction and force of the pulsating flow of pressurized blood. It's like the hose is going to explode if there's too much water flowing too fast through it. It's all got to be very even. Anyway, I'm signing off because I'm tired of talking. Love you all zero of you. I love you.